Let me give you a puzzle. The difference of ages of two friends, Sid and Priya, is 4 years. So what are their present ages? Well, in this case, the age of Sid and the age of Priya are the two unknowns. So let us represent them with variables. So we represent Sid's age by a variable y and Priya's age by variable x. So we have y minus x is equal to 4. So this is what we have. Y minus x is equal to 4. Now this is an equation in two variables, x and y. We have already learned that if we have just one equation, we cannot get a unique solution for two variables from that equation. So, from this equation, you cannot tell me what is the correct age of Sid and what is the correct age of Priya. So, let me give you one more hint. Well, 2 years ago, the product of their ages was 5. So, 2 years ago Sid's age into 2 years ago Priya's age is equal to 5. So let us represent this mathematically. If the present age of Sid is y, 2 years ago Sid's age will be y minus 2. And if the present age of Priya is x, 2 years ago her age would have been x minus 2. So we have y minus 2 into x minus 2 is equal to 5. This is what we have. Now let us simplify this. So y into x is yx. Y into negative 2 is negative 2y. Negative 2 into x is negative 2x. Negative 2 into negative 2 is plus 4, which is equal to the right hand side, that is 5. So this is what we have. Now take this 4 to the right hand side. So we have xy minus 2y minus 2x is equal to 1. Now this and this, these are two equations in two variables x and y. So these two are the two equations in two variables x and y. And we can solve them to find the values of x and y. So let us see how we can solve them. So these are our two equations. Now from equation 1, we have y is equal to 4 plus x. This is the value of y which we get from equation 1. We can substitute this value of y in equation 2 and then solve it. So let us substitute this value of y in equation 2. So we have x into, in place of y, we write 4 plus x. X into 4 plus x minus 2 into 4 plus x minus 2x is equal to 1. So this is what we have. Now let us simplify this. Simplifying this, we get 4x plus x square minus 8 minus 2x minus 2x is equal to 1. Now 4x minus 2x is 2x. 2x minus 2x is 0. So these three get cancelled. So we are left with x square minus 8 and we bring this 1 to the left hand side. So x square minus 9 is equal to 0. Now this is an equation in one variable x. So this is one equation in one variable x. But observe that this is not a linear equation because the power of x is 2 here. So this is not a linear equation. Also observe that the left hand side is a quadratic polynomial, x square minus 9 is a quadratic polynomial. Do you recall what are quadratic polynomials? Quadratic polynomials are the polynomials of degree 2. So the general form of a quadratic polynomial in one variable is given by this. Here the variable is x and a, b and c are the constants. So x is the variable, a, b and c are the constants here. This is a quadratic polynomial in one variable. Note that a cannot be 0. Because if a is 0, this part goes away and that is no longer a quadratic polynomial. Now when you equate this quadratic polynomial to 0, we get a quadratic equation. So this quadratic polynomial equated to 0 gives us a quadratic equation. So this is the general form of a quadratic equation in one variable x. Now can you tell me whether this is a quadratic equation or not? We have x square is equal to 9. Now we can write this as x square minus 9 equal to 0. Compare it to the general form of a quadratic equation, which is ax square plus bx plus c equal to 0. Now, in this case, the coefficient of x square is 1. So we can say a is equal to 1. There is no x term. So we can say that the coefficient of x is 0. That is b is equal to 0. The constant term is negative 9. So c is equal to negative 9. And we have a 0 on the RHS. So we have compared this to the general form of a quadratic equation. And hence, we can say that this is a quadratic equation. So yes, this is a quadratic equation. Now, we know that a solution of an equation or a root of an equation is that value of the variable at which the left-hand side of the equation becomes equal to the right-hand side of the equation. That is, the value of the variable at which the equality holds. So, the solution of an equation is the value of the variable at which the equality holds. Now, if you consider this equation, what will be the solution of this equation? It will be that value of x at which the left-hand side becomes equal to the right-hand side. Now, we can rewrite this equation as x square is equal to 9. We have simply transposed this negative 9 to the right-hand side. So, x square is equal to 9. Now, x is a number which when squared gives you 9. So what is that number? That is the square of which number is equal to 9? 3. We know that 3 square is equal to 9. So we can say that x is equal to 3 is a solution of this equation. Is this the only solution? No. There is another number, negative 3. Negative 3 square also gives us 9. So x is equal to negative 3 is also a solution of this equation. So this equation has two solutions, 3 and negative 3. These are the two solutions of this equation. So a quadratic equation can have more than one solution as well. So this equation has two solutions, x is equal to 3 and x is equal to negative 3. Both these values of x satisfy this equation. Now if you recall, this is the same equation that we had derived using the conditions for Sid's age and Priya's age. We had denoted Priya's age by variable x. Now age cannot be negative. So x is equal to negative 3 is ruled out. So we can say that Priya's age is equal to 3. And what is Sid's age? We can easily derive Sid's age using this equation, and x is equal to 3. So Sid's age is y, which is equal to 4 plus x. The value of x is equal to 3. So it is 4 plus 3, which is equal to 7. So Sid's age is equal to 7 and Priya's age is equal to 3. So this is the solution to our puzzle, and we have derived it by using a quadratic equation. So a quadratic equation is an equation in which the highest power of the variable is 2.